Hi students, this is AJ sir. Let's study trigonometric equations. 9th standard ICSE Math, chapter 23C. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information. In order to solve this exercise, we need to know these values from the table very well. In the exercise, let's start with sum 1.2. They've given a trigonometric equation and we have to solve it and get the value of A. So first we send 2 down here so that cos 2A becomes equal to half. Now we know that this value is present in the trigonometry table for cos 60. So now we can compare and state that 2a is equal to 60. That doesn't mean that we have cut cos and cos. No, this is comparing. And if 2a is equal to 60, 2 goes down and a is equal to 30 degrees, and that's how we find the value of a. 1.4, sec 2a is equal to 2. How do we solve that? Give it a try. Is this the way you solved it? 2 is nothing but sec 60 from the table. So on comparing, again 2a is equal to 60, and once again we got the value of a as 30 degrees. That's just coincidence. Roman number 6, tan of 3a is equal to 1. Give it a try. So 1 is tan 45. So on comparing, 3a is 45 and a is 15 degrees. Now in question 2, let's solve Roman number 2. Tan a minus 1 multiplied by cosec 3a minus 1 is equal to 0. Now here, one of these two brackets has to be equal to 0, or maybe both are equal to 0. So either this is equal to 0 or this is equal to 0. Only then will the multiplication be equal to 0. This is like solving the usual algebraic equations. The same rules apply here as well. So that's how we are going to solve 2.2 and 2.4. But before that, solve Roman number 8 by the same method. Root 3 goes down and 1 upon root 3 is cot of which angle? Cot of 60. So this is the way you must have solved 1.8, where we got the final answer of A as 30 degrees. Now, as I said in 2.2, either this bracket is equal to 0 or this one is equal to 0. So these are two separate sums combined into one. So solve this as we did in the previous sums. Tan A is equal to 1, but 1 is nothing but tan 45. That means A is 45 degrees. Similarly here, minus 1 becomes 1 on the RHS, but 1 is cosec 90. That means 3a is 90 by comparing, and a is equal to 30 degrees. So a has two values in this sum. In the same way, we solve Roman number 4 as well, where either this is equal to 0 or this is equal to 0. Then solve ahead, and by comparing you get two values of a. Either a is 30 degrees or a is 15 degrees. Now let's solve question number 4. An equation is given. They have mentioned that the value of x is between 0 and 90. This bears no consequence while you are solving, because in the table in our syllabus we have studied only those angles which are between 0 and 90, including the 2. Yes, trigonometrical ratios of angles greater than 90 are also possible, but that is not in our syllabus. So solving this, how can we get the value of x first of all? Because once we find the value of x, the remaining parts become easy. We solve it using the usual algebraic method. First of all, 1 minus 1 goes on the other side and becomes 1. 4 goes down, so it becomes 1 upon 4. Square shifts to become square root, so that becomes half. No need to write plus and minus here in trigonometrical equations. And now, which angle of cos gives you the value half? If you remember the table values, it's cos 60. So by comparing, x is equal to 60. And then Roman number 2, we know that sine square x plus cos square x is always equal to 1. That's an identity. But they want us to solve it further and prove it equal to 1. That's why we found the value of x. So let's substitute the value of x as 60. Write the respective values. Don't forget to square it. And then obviously the answer will be 1. Similarly, for Roman number 3, substitute the values of x as 60. Get the values from the table. Cos 60 is 1 upon 2. Squaring that is 1 upon 4. And tan 60 is root 3. So squaring that becomes 3. Here the 4 goes up. Denominator goes to numerator. And the answer is 1. If you notice, even this is an identity because 1 upon cos square x is actually sec square x. And sec square x minus tan square x is equal to 1 always. That's an identity. So knowledge of identities will help you avoid any silly mistakes. So learn them well as well. Now let's solve 6th sum. Mark it as IMP. First, we'll have to find the value of sine A. We can't do it directly here. We can't remove the 3. No. So first we'll have to compare and find the value of 3A. Then find the value of A. And then find the value of sine A. So try it on your own first. Pause the video. So 1 is actually sine 90. So 3A is 90. So A is 30. And then they want us to find the value of sine A. That's sine 30, which is half. Now to find the value of cos 2A and this expression, all we required was the value of A, which we have already found in the process of solving Roman number 1. So we'll substitute the value of A and solve further. When we substitute the value of A as 30, we get cos 2A as cos 60, which is half. And this expression also is easy to solve. Just substitute A as 30, substitute the values from the table, squaring, don't forget that. And the answer is minus 1, which makes sense because 1 upon cos square A, as I told earlier, is sec square A, and tan square A minus sec square A is always equal to minus 1. We have an identity, but it's the other way around. It was sec square A minus tan square A is equal to 1. 8.1, if sin x plus cos y is equal to 1 and x value is given, find the value of y. That's very easy, hardly an inconvenience. So we substitute the value of x as 30, whose value is half, sin 30. So that goes on the other side, becomes minus half, that's half again. So cos y is half, compare it. So cos y is cos 60 and y is 60. In the 10th sum, a diagram is given. First, they've asked us to find the value of tan theta. Well, we know that tan is always opposite upon adjacent. So that's going to be 5 upon 5, that is 1. And tan of which angle is always 1? That's right, 45. So that's how we'll find Roman number 2 theta's value as well. And once we find that, we can substitute it and find Roman number 3 as well. So first find tan theta. Using that, find the value of theta, 45 degrees. Substitute that to get the value of Roman number 3, which incidentally is 0. But note, this is no identity. The value is not always equal to 0. This is a minus here. Now in Roman number 4, they want us to find the value of x. X is the hypotenuse here. We could have done Pythagoras theorem to get the value of x. But they said use sine theta to find the value of x. So let's use that. Sine theta is AB upon AC, that is opposite upon hypotenuse. But theta we know is 45 in this sum. And sine 45 is 1 upon root 2. Also, AB's value is given as 5. So now cross multiply and get the value of AC, 5 root 2, which would have been the answer even if you would have used Pythagoras theorem. Now the 11th sum. 11.2 is IMP. Again, consider this as a usual algebra equation to solve. I see totally 4 terms here. 1, 2, 3, 4. So we'll group them into 2 groups. We'll try to remove something common and solve ahead. So here, if I notice tan A and tan A, that's common. So remove that common. So what is left will be in these brackets. What is left here? 1 minus, what's left here? 2 cos A. Okay. Here nothing is common, so let's take 1 plus 1 as common and just copy this in the brackets, and that is equal to 0. Notice that the RHS has to be 0, only then we can solve this sum. Now, I was expecting these 2 brackets to be exactly identical, but they are not the same. What if we flip it? Then it will become the same, but when we do that, the outside sign changes. So, and this works only if there is a minus sign here. So whenever you flip a subtraction in the brackets, the sign outside changes. So the reason we are doing it is to make sure that the 2 brackets are same, so that we can take it out common. So what is left now? Tan A minus 1 is left, so that goes in another bracket, and that is equal to 0. And this looks like a sum we've solved, such a type. Either this bracket is equal to 0 or this one is equal to 0. So respectively you solve ahead, and by comparing you get 2 values of A, which is either 60 degrees or 45 degrees. That's exactly how we'll solve Roman number 4 as well. The only difference is that on the RHS we did not have a 0, so send it to the LHS, it'll become minus 2 cos 3A, then we'll have 4 terms. Do the grouping, take out common, do the flipping, change the sign, get 2 brackets in the end whose multiplication is equal to 0, solve them separately to get the values of A, which is either 20 degrees or 15 degrees. Next, let's solve 12.2. Cos of x upon 3 minus 1 is equal to 0. Now note that there is no bracket out here. If there was a bracket, that means that entire thing is the angle. But no, here the angle is just x upon 3 and minus 1 is just a number which can be shifted to the RHS. So let's do that first. Because after that, we can now convert this into cos 0, because cos 0 is 1. And by comparing, we can state that x upon 3 is equal to 0. That means x is 0 degrees. So notice that while solving, I never put the degrees, which is not important. But in the final answer, we should always put the degree sign. In question 12.4, if you notice there is a bracket, that means you cannot shift minus 30 on the right hand side. This is entirely one angle. What you can do is comparing. So 0 is actually cos 90. That means this angle is equal to 90. And now it's a normal algebra sum. Minus 30 can be shifted because there is no trigonometrical ratio left. And x is equal to 60 in the end. Same way we can solve Roman number 6 and Roman number 8 as well. Note that in Roman number 6 first, the square will go and become square root. Only then this will become tan 60, and on comparing we get the value of x as 65 degrees. Similarly, in Roman number 8, we will convert this into cos 30. On comparing, we get the final answer as x is equal to 40 degrees. Now, Roman number 10 is IMP. So first we'll have to substitute the value of 30 as root 3 upon 2. Don't forget to square it. Shift it to the RHS. So 1 minus 3 upon 4 will become 1 upon 4. Again, the square will be shifted so that becomes square root of that, 1 upon 2. And cos of what gives you 1 upon 2? Think about it. Well, it's cos 60. So by comparing, x is equal to 60 degrees. Now, Roman number 12 sine square 60 plus cos square 3x minus 9 is equal to 1. So here we can substitute the value of sine 60 first and square it, shift it, comparing and all. But I'm going to use a different approach here. I know that sine square theta plus cos square theta is equal to 1. It's an identity. So I'm going to use that, which will make the sum very simple. So that means that this angle and this angle has to be exactly same. Only then will the sum of their squares of sine square theta plus cos square theta will be equal to 1. So if 60 is equal to 3x minus 9, we can solve this and get the value of x as 23 degrees straight away. And finally, let's solve the 14 sum. It will be better if we draw a diagram for this and then find all these values. So you will notice this is exactly like the 10th sum. So first they've asked us to find sine x, which is opposite upon hypotenuse. The values are given, so we can get the answer as root 3 upon 2. Using that, we can even find the value of x, which turns out to be 60 degrees on comparing. So it's like a 30, 60, 90 triangle. Since we know the value of x, we can find Roman number 3 tan x as well. And then in Roman number 4, we will use the value of x to find the value of y. You see, cos x is nothing but cos 60, which is half. But cos is always adjacent upon hypotenuse. We know the hypotenuse is 2, so the adjacent will be how much? Well, on solving, we get it as 1 unit. If we cross-check this with Pythagoras theorem, it would work out. Y is indeed 1 unit.